So a very warm afternoon, a very warm welcome. Great to have you with us. My name is Kim. I'm the Communications and Outreach Coordinator at UCL Biochemical Engineering. You should have just heard a little voice alert to let you know that this session is being recorded. So after this is finished, in the next couple of weeks, we'll send a link to everybody who registered to let them know that they can watch this back. So this is the webinar for the Synthetic Biology MRes program, the one-year program. Just let you know how the session is going to work. Shortly, I'm going to hand over to my colleague, Dr. Darren Nesbeth, and he will talk to you about the program, and at the end, we'll do a Q&A. If you have any technical problems, let us know in the chat. You can let us know at any point. We'll see that come through. We're more than happy to deal with your questions. We look forward to them. If you could put them in the Q&A box, that'd be really helpful. It just helps us order things. Sometimes we get a lot of questions come in. It's easier to answer them. And sometimes it's a bit easier. We need to send a response in writing. So it's easier if you use the Q&A box. Any problems at all, let us know in the chat. If I turn my camera off, I will be here in the background. I'll just let you, I just won't distract. So after Darren's talk, we'll do the Q&A. And yes, I'll also put my email address in there. If anything occurs to you afterwards that you didn't ask at the time, you can always email me. Okay, Darren, over to you.
Great. Thanks a lot, Kim. Shall I aim for about half an hour? Or less, or more, or that's fine. So it's great to see everyone here, or many people. Yeah, thanks again, Kim, for the intro. Lovely to see you all from various locations. So today I'm just going to talk you through the MRes program, MRes Synthetic Biology at UCL, where the home of the MRes and the content of the MRes in essence. So let me now just share. So that should be my whole desktop. So I'm now going to go to full screen. So that should just be the first slide, I hope, right? Bear with me.
Yep,
okay.
That looks great.
Right, so yeah. So my name's Darren Nesbeth. I'm an associate professor in the Department of Biochemical Engineering, and I'm the program director for the Master of Research program in synthetic biology. So I'm a molecular life scientist by background, by original training back in the day, but I've worked in interdisciplinary teams with engineers, computer scientists, biotechnologists, large people that want to scale up solutions that will really help people in the real world, and with companies. So that in fact fits well with synthetic biology as a concept and an academic mission that encompasses multiple disciplines, multiple interdisciplinary teams, ranging from pure life scientists through to engineers, modeling people, chemical engineers, molecular biologists, and so on and so forth. So because of that, the MRes actually welcomes and it considers itself a conversion masters in a lot of ways for people to come from a variety of different backgrounds spanning those areas. So so the course is designed to welcome people from a variety of disciplines and give them this opportunity to gain these key skills in synthetic biology research. And again, in terms of the course, it is largely wet lab based in terms of the research projects, and the teaching content, but also adaptable and has the capacity to support anyone who'd wish to do maybe a more modeling or computational project. So this is University College London is the university which offers this program. It's the only program in the UK purely in synthetic biology. So there's other programs in something and synthetic biology or synthetic biology and something, but this is purely synthetic biology. And also, unlike a lot of universities in the UK that offer synthetic biology or synthetic biology adjacent type programs, this synthetic biology program resides within the engineering sciences faculty. Now, that's quite critical, in fact, because you don't need to ask me, you don't need to take my word for it. I think if you search in any capacity, it'll be clear that engineering faculties have more direct connection with industry, typically more than any other departments within universities. So structurally, everything within engineering faculties is structurally guided by real world industrial application. And in many ways, that's the definition of engineering. And so we think that's a particular advantage of uh, choosing UCL for your synthetic biology qualification, because other departments can have a larger extent of other universities and in other departments may have a larger degree of fundamental research, so not necessarily applied. So structurally, they may not be as tuned towards company collaboration and industrial impact as a synthetic biology program that sits within an engineering faculty. That's not to denigrate any of the other programs across the UK. They're all excellent programs, but this is what we think is one of the strengths of the UCL Synthetic Biology MRes program. Having said that, another positive of UCL is academics and research labs who identify as being synthetic biology research centres are actually spread relatively broadly through all those departments. So that gives you a diversity in terms of guest speakers and host departments for projects with potential projects within your MRes. So if you weren't aware already, UCL is a research intensive university that's successful on the global scale. So there are many rankings each year, and UCL is always in the top 5, 10, or 15 of all those rankings globally, and always very high within UK rankings in terms of its research strength. We're very heartened to receive the Sunday Times University of the Year award last year, but we are constantly up that little box in the top right. We're always updating it, and it's always with very high rankings globally. So having a degree from a university with a globally recognized brand is always a value add, considering the costs of degrees when you're thinking about your decisions. Okay, so these are the 10 departments within our faculty, and again, there is much cross communication and interaction across all the departments within the faculty for a number of reasons, for research, for reasons of teaching. There's actually, for undergraduate engineering degrees, there is the first term of teaching actually is common to all these departments. So that level of integration between the departments, again, is very beneficial for the environment that you'll be a part of as an MRes student at UCL and at the UCL engineering faculty. So biochemical engineering actually historically was born out of the chemical engineering department in the late 90s. And again, that attests to the rigor of the engineering in the MRes synthetic biology home department. So these are just some connections, some of the more high profile connections in terms of globally recognized companies that the faculty has research collaborations with. There's also, our department, Biochem specifically, has had, from its inception, industrially sponsored research and industrially sponsored doctoral studentships. So it's just inherent to how the department functions. So most recently, there's a global biotech company, Cytiva, that has a large collaboration. We also have ongoing collaborations with AstraZeneca. And there's a company called Oxford Biomedica that also works in the synthetic biology space. Two synthetic biology companies actually span out of UCL Biochem Eng. So one of them is called Synthase, which is a kind of computational engineering software focused company in the realm of synthetic biology. And you may have heard of the company called Bento Lab, which is the small portable molecular biology laboratory about the size of a laptop suitcase, briefcase. So that was a spin out of from UCL Biochem Eng as part of the student synthetic biology competition called iGEM. So again, there is structural support for careers within this university. So as a UCL student, it's immediately becomes, we have a common interest in that the university wants its graduates to do as well as possible. And obviously, as a graduate, you will want to do as well as possible. So we're both pulling in the same direction, and there are structural supporting networks in terms of guidance in general at the university that it offers. And there's also specific within our department opportunities to attend events and talks given by speakers from external companies, and to actually interact, study alongside professionals from biotech companies on short courses or seminars that may be taking place in the department. Okay, so that's a very well supported element of how we work. A common question people have, and a common concept people come to an MRes with, is the feeling that they can only apply for doctoral students towards the latter stage, doctoral studentships, towards the latter stages of their MRes program. So in the UK, I can speak for that authoritatively and pretty confident in the US as well. It's actually understood that you would start applying for doctoral studentships literally the first day of your MRes. So they understand you've only just begun the MRes, but these would be for an opportunity. So if you started the MRes September 2025, you should apply for doctoral studentships that start September 2026, if of course you wish to do a doctoral studentship. And we will write those reference letters for you and support that application. But it's understood as part of the calendar within UK research environment that people doing master's degrees apply for doctoral studentships in the first 2 to 3 months of starting their masters. So there is no expectation that you have to wait until you've seen the first results from your project right through to June, July 2026 in order to apply for doctorates. So I'm telling you right now, you will have opportunities for doctorates with a September 2026 start that you should apply for in 2025 at the very beginning of your MRes journey. Very important point, that one. Okay, so these are just some of the highlights of the research carried out across the department, across the faculty. You can see there are many and diverse research achievements. Particularly during COVID, there were some major achievements in terms of respirator tech that were rolled out and developed at lightning speed just to help the UK national effort during COVID, and people have been recognised for those contributions. That was in mechanical engineering, and our department also worked closely with Oxford University and AstraZeneca with respect to developing scale-up technologies and implementation for vaccines. So if you follow that link, there's a number of video or audio presentations by disruptive thinkers across our faculty, including Professor Martina Micheletti on the subject of vaccine technology from the UCL Biochemical Engineering Department. And so, some of these projects and some of these concepts presented by these disruptive thinkers will be projects that are actually offered or will cover topics that are actually offered as MRes research projects. Okay, so there are some scholarships and bursaries to support you to do an MRes in the UK, depending on your status. The main thing there is to inform yourself, to get that information. So don't getting the correct information allows you to move forward with your expectations. So perhaps you think there's more opportunities than there are, perhaps the number of opportunities you think are actually less than there are. The best way to just replace curiosity with knowledge and find out as much as possible, as soon as possible, about scholarship and bursary opportunities. And again, you can email, you've got our contact details of Kim and I and our colleagues. At any time, we're always happy to point people in the right direction or provide them with information that we have regarding any scholarship or bursary opportunities, and to provide any assistance or guidance where appropriate. This is going to be some clicky, right? Okay, so this is part of the history of the UCL Biochemical Engineering Department. So arguably, you could say it goes all the way back to the 50s when UCL graduate Francis Crick, although he wasn't working at UCL at that time, attended the anatomy lecture theatre, which you're welcome to pop round to if you join the program, and taught the central of molecular biology, which is DNA makes RNA makes protein, at the anatomy lecture theatre in 1957. So that was actually the first time in human history that the central dogma was uttered in a lecture. So if you contemplate how many times the central dogma has been taught since that day, I'm sure that runs into many millions of times, but the first ever teaching of the central dogma happened on the campus where we have this, our MRes program. Then we moved to the 60s, and some of the founding professors of the department had a key role in basically tech transfer of the penicillin manufacture to a more scalable E. coli-based process. Quite rightly, the discoverers and the early developers at most need have the most profile when it comes to penicillin. But in terms of penicillin becoming mundane, just an everyday expectation of society, arguably right through to the modern day, where some people are even skeptical about the modern world that's been enabled because of these types of medicines. That transition to mundane, large-scale manufacturing of penicillins was spearheaded by professors like Malcolm Lilly and Peter Donnell, who were very important founders of the UCL Biochemical Engineering Department. So fast forward to the late noughties. So the International Genetically Engineered Machines competition is an international, largely undergraduate synthetic biology competition. And UCL entered its first team in 2009, soon in the early years of the IGM competition being offered. And so myself and Professors John Ward and Ellie Keshavars-Moore were members of the supervisory team for that first UCL IGM team. And so Professor John Ward was the founder of this program. So John and I have known each other going back to then and earlier. So when John retired, it was a natural progression for myself to then take over the directorship. And so it was around that time, inspired by some of that early IGM activity, that John secured the funding to launch the MRes program. So as you can see, that's for the 25-26 year of the program, that'll be 15 years the program has been running. So there's a wealth of experience in terms of how to, sorry, I've got something obscuring. Can everyone see that software update sign? Maybe I'll.
Yeah, I'm afraid so.
Let me get rid of that then. Okay.
Thanks.
So yeah, so as I was saying, we've got a wealth of experience in terms of how to ensure students get the most out of the program. So the critical delivery of an MRes program is students that have embedded those core research skills that will empower them to go on to successful careers in research, whether that's academic or industrial. And we firmly believe that those skills are also transferable So in essence, to any professional calling that they go to afterwards, the deliverable of the program is excellently trained early career professionals. Again, philosophically, it's worth keeping that in mind, in as much as it's a studentship, it gives you that research training. What the MRes doesn't do is have specific research questions and in any way simply use students as lab labor to answer specific research questions. Although in a sense that may seem like an exciting thing, we've got these research questions, we've got these early career researchers. That's actually, as described, that's not actually a training activity, because to prioritize research question is something you would actually do with professional researchers who have all their qualifications behind them. So do keep in mind the MRes program it's a studentship, it's a training opportunity in which you will achieve certain training outcomes, certain in terms of your skills and your experiences. Okay, so my colleagues teaching on the program. So there's myself up the top right. So in terms of my research interests currently, that they tend to be around the areas of applying synthetic biology to lab-grown meat or cell and gene therapy. I've written lab-grown meat there. You could call that cultured meat, you could call that cultivated meat. I think everyone understands broadly what that is. My colleague Steffi Franks is a wizard at designing biologically synthesized kind of nano devices. Mike Thomas leads the actual research project module and works at the London Centre for Nanotechnology, which is a joint institute between UCL and Imperial. And again, Mike's research interests are in nanotech. Leonardo Rios, who's now who will be the lead on a module called Advanced Synthetic Biology, teaches CRISPR technology and other technologies as they're applied to things like yeast metabolic engineering. Professor Paul Dolby is a very eminent expert in the field of directed evolution. Some of you may be aware that that's a field that recently earned a professor at Caltech, Francis Arnold, a Nobel Prize, so a very hot area of research. So Paul teaches that area along with Leo on that course. And Professor Gary Lai, former head of department now, teaches some of the core research skills on that module that you'll see later, we'll talk more about later. And also sustainable scale industrial biotechnology and how synthetic biology can enhance that as a research area. Right, so let me just go through all of these at once, actually. So forgive me, some of those builds. So this is the course structure. At the very top of the course, you can see there is the research project. At 120 credits, that's a very large course in terms of typical course structures in UK higher education, but that's necessary for the Master of Research element of the course as opposed to a Master of Engineering or Master of Science. Although it conveys that the research project starts in term 2, it starts midway through term 1, in as much as you receive a project list and you have the opportunity to meet and speak with the academics offering the projects on the program. So that will actually happen in term 1. There's a possibility of even starting in the lab in term 1, depending on the timeline. But for sure, you will start full-time on the project in term 2. I'll come back to the project, actually, because there's a lot to say about the project. Complementary to the project, you have four formal talk courses. So BN 0044 teach you about those elements of research skills that are actually transferable to many professional settings, and also bioprocess. So that's the industrial application of synthetic biology today to actually help deliver technologies as they arise today in the very short time horizon. So as soon as possible, how do we go from an elegant piece of technology to an actual implemented product or service that benefits mankind right now. Again, BN0097 concentrates on research skills. There are a lot of skills to master. The entire philosophy of the course is looking forward to your future career rather than, let's say, incrementally building on the 3 or 4 year first degree you've come from. The course is a forward-looking course. So that there may be a different emphasis, a different flavor in terms of what the assessments are testing specifically. They tend to test or provide you with that training and then test that training in a way that's focused on the likely environments and challenges you'll have as in a research career. The bottom 2 courses are the actual are focused on the biological knowledge. So all those lovely things like CRISPR, gene drives, Cas9, CAR T cells, metabolic pathway engineering, all those areas of science and engineering that are most famously associated with synthetic biology, you will be given expert understanding of all those in the content of these 2 courses. So I teach BN0040 called Industrial Synthetic Biology in term 1, and my colleagues Leonardo Rios and Paul Dolby will be teaching the Advanced Synthetic Biology module in term 2. I see I've given them both the same code. That's a typo. So the Advanced Synthetic Biology module is BN0045. So going to the research project, I think, because I can't see the questions right now, but I think I'll try and preempt some questions. One of the questions is, can we do my research project that I have thought up? The short answer to that, the short and blunt answer to that is very likely to be no. And the reason for that is partly goes back to what I said earlier. The project is not simply an opportunity to answer a research question. The project is an opportunity for you as an MRes student to gain core research skills in terms of laboratory skills and report writing skills, data analysis skills, data interpretation skills. So a project has to meet certain criteria in order for BN0046 as a module, as an educational experience, to deliver certain learning outcomes. It takes arguably decades of experience to propose and design a project that can, within the timescale, have a good likelihood of delivering the experiences and the data sets in order to give you those opportunity for those skills. So defining these projects, honing them, so not only so they answer a given research question, but so that they deliver the learning outcomes intended, takes a certain amount of skill and experience. And that's why it's unfair really to ask students joining the MRes, who we are training to be researchers, to already be at the experience they can propose a project that would deliver the learning outcomes of BN0046. That wouldn't be sensical. So the projects tend to be, will be devised by UCL academics. That being said, there is always an opportunity inherent for you to have an interaction with the laboratory you're in, an interaction with the research team, everyone on the previous slide, and there are always opportunities to bring your ideas to bear in your research project, and where appropriate or where helpful or where adds value. But certainly it's not the case that we ask the incoming students to devise a project and we have titles and projects devised by students. Second question would be, what is the list of projects? So again, we do not disclose the list of projects from this year or previous years. The reason for that is the project list is different every single year by design. So in order for us to deliver the most cutting edge synthetic biology research projects in 2025, inherently we can't know what those projects already are in November 2024, or they wouldn't be cutting edge. If the project list was a dusty old document with the same projects or the same 8 projects every year, that may be straightforward to deliver, but arguably that's more of a practical, and most people have already done undergraduate practicals. Research is about current research challenges and entering the unknown. So we can't have dusty old projects that have been iterating for several years. So the project list is fresh. The projects, academics across all of UCL beyond the engineering faculty provide projects. And so to keep that list as broad and as diverse as possible, we insist that it's fresh every year. It can take us more or less time each year to finalize what we feel is the best list of projects possible, but they're only disclosed to people who have signed up to the MRes. I can talk to you about the range of types of topics, but we never disclose the project list. Having said that, you can, of course, everyone is free and encouraged to speak to the alumni of the course to discuss the projects and how they enjoyed them. So please stay in touch. There's my email address. I'm personally, I'm on Twitter, but also expanding to some of the other social media platforms. But the most direct and informative route is to just send me an email. I mean, I invite everyone to email me with any questions they have. We've got a LinkedIn group as well for students on the program. There's also a Twitter/X account for the department run by Kim. Okay, so we'll switch now to questions, but please take a quick capture of this so that we can get a sense of how you enjoyed the actual webinar slides today. Okay, I'll just minimize screen and happy to have a discussion and a nice chat with everyone about the program.
Fantastic. Thank you very much, Darren. Great to have that. And if actually, I'll be sending out an email afterwards to everyone who registered, so I can include a link to the survey as well. We've had a couple of questions come in. I'm going to give Darren a chance to read those questions. Somebody actually sent one in before we started as well, so that's in the chat. So there are a few come in already. Just to remind you, if you pop them in the Q&A box, it helps us quite a lot in answering them. Also, you can post them anonymously if you wish, as somebody already has done. Just to let you know as well that if you're on a mobile device, at the bottom of the screen, there are a couple of buttons at the bottom which allow you to configure how you interact with Zoom. So that might make things easier for you. If you want to expand who's speaking and see the questions or see the chat or whatever. You can actually control that on your own device. Okay, Darren, I'm going to hand over to you.
Great, thanks, Kim. So I'll go first of all to the question. This query, I'll just read it out for everyone in case you can't see it. So since I'm interested in in the area of alternative proteins or cultured protein, are there any relevant research currently running? So the answer to that is a resounding yes. So my own lab, we've got currently ongoing research in the area of cultivated food. So we've got a project on cultivating fish meat or growing cells ultimately for lab grown fish meat. So that's one of the projects. Obviously, I can't, like I said, I can't show you the project list, but that is one of the projects for this current year of MRes. I have a colleague, Dr. Petra Hanger, who is the co-founder of a startup called Quest Meat and also a member of the department. And she will also be offering research projects in the area of cultivated meat in terms of, it sounds strange to talk about the types of meat, but yeah, pork, beef, fish in those areas. It's important as well to realize beyond growing the animal cells, cultivated meat will never be viable if the back-end costs don't come down. And a lot of those back-end costs can actually be provided with microbial technology. So you ask yeasts or other microbes to make certain proteins that help the animal cells grow, or small molecules. So that's an ancillary technology, for you could say, that has to be fine-tuned for cultivated meat, and we also offer projects in that area. So our department has many researchers who have been headhunted in the last 5 years to work for companies like many of the cultivated meat companies you may have heard of in the UK. Have at least one or more members of alumni from our department working in those companies. So we're very much embedded in the UK cultivated meat emerging commercial scene, and we will always be looking to have some projects in that area on the project list. So hopefully that encourages people. So yeah.
So I just want to jump in and give a shameless plug to the department. We've got some virtual taster lectures that'll be coming up in the spring, but it's very much one of the focus of our department is cultivated meat and lab-grown foods. So we've got one which is on dodo nuggets and T-Rex legs, which is going to look at the viability of DNA and structures, and the difference between creating something which is maybe a leg, which requires a different technique, to something which might be a nugget. It's got a really scary AI generated image, which we enjoy putting up for that. We're also doing some work on cell-free technology for viral vector medicines. Leo Rios, who was mentioned earlier, he's going to be talking about using yeast to manufacture oils. And we're also doing one on manufacturing mRNA vaccines in such a way that they can actually be transported much more effectively, which will solve some huge global problems. But when I send the email out to everybody as a follow-up to this, as well as a survey, it will have links to those events. Please do sign up and come along. It'd be great to have you there. But yeah, if you're interested in lab-grown food, there are definitely some good talks going on there in the spring. Thanks, Darren.
No, yeah, very good point. Thank you, Kim. I also forgot to mention I have another project in collaboration with universities in Malaysia on technologies to ensure cultivated meat is also compliant with things like halal status. And we've actually got a review article coming out on that soon. So considering all the religious and ethical considerations of cultivated meat, not only now, but in the next 50 years, as synthetic biology, engineering biology potentially throws up more and more new technological innovations that people will need to debate and wrestle with in terms of what views they take on them. So, and that's also an important part of obviously that ethical concern and concern about societal impact is also knitted into the program. So some of you, if you haven't heard, well, I'm sure you've all heard of Elon Musk and electric cars. So the scourge of Elon Musk and electric cars is Professor Jack Stilgo at UCL Science and Technology Studies Department. And we have some academics from that department, again, have sessions with the MRes students and have debates about ethical issues when it comes potentially raised by synthetic biology. So we have another question about lab skills and prior knowledge. So in general, we've had, going back to 2010, we've had students from a broad variety of backgrounds. I myself had a doctoral student who only had qualifications in maths and statistics. So there is an element of challenge and stretch, but there's also an element of awareness from our side that people come from a variety of backgrounds. So the assumption is you'll have some level of biological knowledge, but again, we're happy to fill up any gaps in that. But there's no assumption about lab skills. So you can have 0 lab skills and do very well on this course. We don't assume you've got any lab skills prior to this course. I personally did a PhD after doing a purely dry computer-based undergraduate degree. It was a bit nerve-wracking, but it was fine in the end. So again, in terms of the philosophy of the course, we consider ourselves taking in students from a broad range of backgrounds and giving them that opportunity to have confidence in their synthetic biology skills so that after the program, they have no worries about their competence with wet skills and the concepts of synthetic biology. So we have a question. I think it may be. So I'll skip to the PhDs where I can take some interesting modules. So I'm not sure I fully follow that question in terms of there aren't really. There's the taster lectures Kim has spoken about, but there aren't so much opportunity. There aren't optional modules and a range of modules and so on to pick and choose from. So it's fixed in terms of the program. In terms of grants and visas, I think we're probably best to answer that thoroughly offline rather than make some noises. But we will answer that, Comfort. There's questions from Comfort there. We'll give you a written answer to that, to your query about grants and visas. Because that's not because we have any reservations, but it's always important to be thorough when it comes to dealing with those kind of inquiries. So yeah, but I would say as well, we've in terms of the global diversity of students we've had students from every continent since 2010. There's from various countries in Africa, Asia, and the Americas, and anywhere I've missed. So there's no geographical background or so on that hasn't had previous students on the program. So nothing to, and again, that's why you should feel free always to ask questions, because I guarantee you someone else has asked Kim and I the same question 2 or 3 times down the years as well. So there's no need to kind of have any reticence in terms of coming forward with questions. Okay. If anyone doesn't have a question, perhaps there's some elements of the program anyone would like me to revisit or speak on further.
Yes, so I mean we've blocked out until the hour. So if you have any further questions, any clarification, anything you'd like to develop, we've got another 15 minutes to go if you want to. Otherwise, we'll let you go. I won't keep you unnecessarily, but I'll keep talking a few moments to give you a chance to get any more questions. And I also want to reiterate what Darren said. Please get in touch with me directly. Somebody was asking about modules related to, I think actually the question was, Darren, if they do a PhD in the department, would they be able to do any of the modules from the MRes as part of that? So that's a question that's come up, and I don't know whether that's a thing that's possible.
So the short answer to that is yes. I've currently got a PhD, a doctoral student taking one of the courses. Just depending on the doctoral program, obviously for many doctoral programs, it's a requirement to pass a module. So bear that in mind, in as much as it's not just, let's say, if you're all the way in with that risk of, it's like that disclaimer, people may fail as well as they may pass. So there isn't, I'm afraid, an opportunity at UCL to half-heartedly take a course. You're either all in or you're invited to not take that course. Having said that, when anyone comes to me, there's a lot of content I can direct them to for them to get the information they're perhaps looking for. There is one thing, perhaps, if there aren't any more questions, that I can do. I can just revisit very briefly, just be a very brief little.
So actually, there is a question that's come in, and it's asking about. It's just asking about the how many people there are in the program, how competitive it is. I think it might be worth just explaining in general but also I'll tell you what I'll do. Let me also, as well as letting Darren answer that, I'll put a link to the prospectus because it'll show what the entry requirements are for the program. And I mean, that's probably one of the clearest way of spelling it out of what the entry requirements are. Darren, do you want to expand on that?
Yeah. So, I mean, in terms of the selection, there are the hard requirements that the the well-defined requirements that Kim will share with everyone. But there's also a personal statement element of it. And given what I said earlier, that we expect people to be coming from a broad range of areas in STEM. So in that case, the main thing we're looking at is engagement and motivation. So if you can look to evidence or even just attest to your level of motivation and interest in synthetic biology, that's something we definitely look for. If you take it as read that everyone has got all the other qualifications and or requirements, and that they've got a good first degree, those are the differentiators, rather than this person knows more about synthetic biology already than that person. That's not so much the differentiator. It's that because it's a challenging program, we're looking for it to be as beneficial as possible to an applicant. So it's going to be most beneficial to an applicant who's got high levels of motivation and curiosity about synthetic biology. And in terms of
Also,
numbers, sorry.
so just say in the past, when the programs have become oversubscribed, they will shut down applications. It hasn't happened for the last couple of years, but if we have too many applications to be able to offer places to for the program, because obviously it's not a large program. If we have too many applications, at some point there will be a cutoff. But it's worth keeping an eye on the programs. It's normally advertised that we're closing them down, just to make clear that we don't allow programs to become oversubscribed at UCL.
Absolutely, and I think the main way to ensure, to de-risk your chance of getting a place on the program is to apply soon, rather than leave it to deadline. Apply well ahead of any deadlines. That's what I would say. So, in terms of the numbers, it's typically it's 15, possibly rising to about 20 students, but generally you could expect about 12, 15 students on the cohort. Whoops, let me stop sharing. So there is another important thing to say. So you saw the diagram of the program. So there isn't any room there to actually participate in iGEM as a participant. But there is room. The good news is there is room to participate in a smaller scales international synthetic biology competition called GOGEC. I think if you look up GOGEC conference, so that's GOGEC. So that's an international student synthetic biology competition where you can just propose the concept of a project and enter your concept into the competition, give a presentation, and so on. So UCL MRes teams for the last 3 years, this will be the third year that UCL MRes teams have entered into that. For UCL MRes teams to participate in GOGEC, that's one opportunity that we could completely ring fence to be totally autonomous and student-led. So outside of professionalism and conduct, there is no staff gatekeeping or telling you what to do within the GOGEC activity, because it doesn't require laboratory time, but it does require creativity, teamwork, and so on. So it's always been a very good way as well to develop the cohesion of all the MRes students and give people an opportunity to work together, persuade each other, talk to each other. And it's been going very well. So this year's the 24/5 MResers are very enthusiastic and enjoying exploring concepts for GOGEC, and also the fact that's not a UCL module, so that's a thing where UCL, the MRes students have autonomy. They don't have staff telling them what to do all the time. And again, that's also part of our department's philosophy. So the majority of UCL iGEM teams have been student-led as opposed to staff composing a situation for the students. So one last thing, and if there's another question, maybe I can do both. So comfort, is that be a similar session for a PhD? So for doctoral programs, again, um, the the projects tend to be predefined. So, I mean, it's not impossible for a student to come along with a project and it end up being the project, but it's highly, 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 highly rare. So generally, you would apply for advertised opportunities for doctoral studentships at UCL, and there are many synthetic biology focused doctoral studentships. So I just wanted, mindful of time, very quick point without me talking for too long. So this may come to a surprise to some of you, but I think it's worth, again, showing you how kind of fresh and perhaps the program may not be exactly what you think it will be, but in a good way. The most difficult thing about the research project is actually stepping the project down in August, September and delivering a research report, because every MRes student very much falls in love with their project and becomes engrossed and committed and energized by the project. So it's actually, but this is a very good research skill learning opportunity, in as much as you have to learn the pain of distance. So keeping a certain level of distance, emotional distance from the project, in order to ensure that you also do the work necessary for the project's deliverables, which for you will be a research report for BN0046. So many people come to an MRes thinking the most difficult thing will be mastering laboratory techniques with their hands, mastering CRISPR, getting cells to work, mastering gene drives and all these Golden Gate assembly and all these famous technological aspects of synthetic biology they've read about or heard about. So they assume being able to do those things will be their biggest challenge. You will be taught to do those things, but that won't be your biggest challenge. The biggest challenge will be stepping back from the project and transitioning to, now I have to write my report. And I think that's a good challenge. And it's a challenge that's beyond just learning knowledge and passing an exam and so on and so forth. It's almost like an emotional challenge for how you develop yourself as a person, as a researcher going forward. So I think that's quite a unique opportunity that is brought by doing an MRes, I think, that you can't get from more talk-based programs. So that I just wanted to make that little point, and hopefully that will be something that fires your enthusiasm out there, and maybe it's something that you hadn't thought of. What are the challenges and main aspects of MRes study? Okay, right. So I'll stop sharing now. Final check for questions. Looks like everyone's happy.
I think so. And I mean, I've said this before, but please, if you have anything that you'd like to ask that you didn't get a chance to ask today, or you'd like us to expand on that occurs to you afterwards, please just email me. I will contact you in the next 2 weeks, but I've sent everyone who registered an email, so you should already have my email address. Just reply to me and I'll be more than happy to put you in touch. Somebody asked about PhD programs. Again, just get in touch with me, drop me an email. I'll be absolutely delighted to put you in touch with our postgraduate research team. They'd be very happy to help you. And yeah, so that's it. Thank you very much for joining us. It's been great to have you here today. Sorry, someone has just asked if there's a faculty scholarship for international students. What if you send me an email, I can send you a link to our page which will give you details of scholarships. It's across UCL because it'll cover a whole range of PGT programs. But you can look onto that, and they change throughout the year as well. So contact me, and I'll send you a link to that. As with everything else, if there's anything that you want to get in touch with, please get in touch. And yes, sorry, let you know, I will put my email address in here, and whilst I'm doing that, I'll let Darren finish off.
Yeah, so while Kim just lets Solu know the email address, I just want to thank everyone for attending today. Huge thank you for your interest in the program. It's always great to see people have got curiosity about this program. Strongly encourage you all to submit your applications. I look forward to going through the personal statements of those of you that do. Please just give it your best shot, apply, and hopefully we'll see you all in September 2025 as you start the program. So thanks.
Thank you very much. Great to have you with us. Bye, Darren. Thanks very much. Bye bye.